stage.
So, how often do you refactor code? And when you do refactor, are you happy with it? Does it work out? And if it doesn't work out, why not? I'm Steven, and I'm here to tell you how to make sure that you refactor more code, how to make sure that you don't go over time, and how to make sure that you deliver what you actually promised when you started refactoring. And so let's start out with the nightmare scenario. A couple of years ago, I was asked to help out a team. The team was working on a project. The project was already going over time, and they were in a pretty bad spot. So I joined the team for a couple of months, and the code was pretty bad. I'm sorry, Sonia. The code was in a pretty bad spot. So what had happened is that there were multiple teams working on the same small code base for a bunch of time, and everybody had just started hacking in the code. Nobody felt responsible, so it was just hack on top of hack on top of hack. And everybody working on it was very unhappy with it. So what they would have is, on the backlog, you have a Jira ticket that says refactor class X. As a developer, I want to refactor this code to make it better. What can you do with that? And the problem with these stories is that they were never actually put into a sprint. Because the product manager, well, back then they were still product owners, the product manager just looks at that and goes like, oh, it's time to try one of them again. Put them into the sprint, and then they take 2-3 weeks, they get way over time, and when they're done, nothing has really changed. It hasn't really gone any better. This is a vicious circle because the code doesn't get better, and the product manager feels like the trust has been hurt. They're not going to put the story into the sprint again. So those refactor stories, they all bunch up back on the backlog. They never appear, and it's a vicious circle where the code gets worse and worse. And the worst part here is that nobody was in the wrong. The developers weren't in the wrong, and the product managers weren't in the wrong. They just didn't really know how to fix the situation. So, what is refactoring? Refactoring is changing the structure of the code. And as I was looking for this, like the definition of refactoring, making it better. Well, yeah, no, of course we're not trying to change the structure of the code to make it worse. Come on, we've got better things to do. So, but the most important part is that we're not Boy Scouting. Like, we're not just, change the name of a method, move a method, change the order of things, extract a variable. We're not Boy Scouting. We're just doing the real things. It's not things that are trivial to do with your IDE. So you want to do things that really change the structure of the code. Most important part is that we're not trying to rewrite the entire code base. You should never try to rewrite your entire code base. There's a great talk about that from Roy later today. Check it out. But most of all, in my opinion, refactoring is an art. It is subjective. Everybody has different opinions about what good code is or how to refactor code. But most of all, it is not a skill. It is a skill that you have to practice. You have to get better at. You have to learn. And you have to do it often. You can't just wake up and think, oh no, today I've never painted before. I'm going to paint the fucking Mona Lisa. Of course not. But just like art, I cannot teach you how to paint the Mona Lisa. I can just give you the skills and the tools to get better at it. But you have to do the hard work yourself. So when you have to refactor code, usually it's very important that there is some kind of trigger. There's a reason why you have to start refactoring code. This can be, for example, change request. Like you have to add a new feature, and you look at the code, and you're like, it's going to be really hard to do with this code base. It can also be, you have to fix a performance issue. But to fix the performance issue, you have to radically restructure your code. But it can also be something more subtle. Like, for example, you're in a retro. You're talking with your teammates like, we had this bug on production caused by a story of us. But really, it was so hard because of the code to program correctly. It's very easy for bugs to creep in. Or, it takes a lot of work to add these new features. That's a very good trigger to start refactoring. But in my opinion, the most important part is that you always need some kind of trigger. You can't just start refactoring code without a reason. If you are not touching code, just leave it be. You can always find a better opportunity to start touching again. And the reason why this is important is because if you don't refactor code without a trigger, you don't have something to hold it towards. Like, how can you judge that what you did was correct? And when you start refactoring code, the first thing that you need to do is to define for yourself a clear goal. What do I want to accomplish with this refactor? And this can be one of many goals. So for example, you can say, well, I want to make sure that I have less duplication in my code. Or you can, for example, say, well, I have these business rules that are all across the entire code base. I want to make sure that they are contained in one single class. But it can also be, well, I've got this one class, and it's a humongous class, 10,000 lines, all with all the business rules. I want to split it up into multiple ones. And what you can see here is that these goals can actually be contradictory. So code is not always good code. It's subjective. Some code is good for certain things, and some code is good for other things. As an example, one thing that you might want is you have an inheritance structure that is extremely complex, and you want to break that up and to make it easier to read. Well, one of the ways to do that is to remove complicated inheritance and to introduce duplication. Well, one of the things we always learn is, well, you don't want to duplicate your code. Well, sometimes it's the lesser of two evils. One thing to think about is scalability. So, for example, imagine you are creating some kind of software that interfaces with warehouses. When you start out at a small company, you have the warehouse. You only have one warehouse, of course. So you make code and you just have, you just call the warehouse. Well, when you start expanding, you might have multiple warehouses, and you have to think of a solution on how to fix that issue. So, for example, you might have enums, you might have some inheritance, subclassing. There's some ways to solve that. But then, let's say you go global. You are adding one warehouse every week. You have hundreds of warehouses. Well, you can't have one enum with all the warehouses in it. That's insane. So you have to start thinking about, maybe you have some database to hold all this information. And then you get radically different solutions. So one thing that I like to do when refactoring code is to consider the past. How did we get here? And something that resonates probably with a lot of people is, you have to start a new service. And you start thinking about, all right, what does it need to do? What are the functional requirements or the non-functionals? How many things do we need to do? What are the skills? How many products are we going to have? And then based on that, you make some kind of design. And then you start building. And then it slices 0.9. You didn't even finish the first slice. It has to go live, MVP. And then you have to work on a different project. Slices 2, 3, 4, 5, 6 that have all been planned, never going to work on them. And then a couple of years later, someone opens the code base, it might even be you, and you look at the code, you're like, oh my God, what did they do? How can you think of this? There was one warehouse, and they're reading it from a database. The thing is, you shouldn't hate the code. The most important part is we all have to make bets, and sometimes the bets don't work out. You just have to read the code, learn from it, but the most important part is to understand why it was made. And maybe you can learn something. Sometimes you just look at code and you're like, oh, this is horrible. The more you read it, you realize, oh, it's actually not that bad. They actually did this to, solve a different problem that I hadn't seen yet. So one of the absolute biggest pitfalls of refactoring is that people want to refactor everything. They want to refactor the whole code base. And this is a really big problem. You shouldn't try to be the Goliath. You shouldn't want to be the big guy. You have to be the little guy. You have to be David, the agile guy, not Goliath. So it's such a big pitfall to start to try to refactor the entire code base because of three things. The first one is it takes a long time. And that's a really big problem by itself. You're working on refactoring the entire code base. It takes a really long time. Your product manager starts getting nervous. That's annoying by itself. Second one is it is very likely for bugs to creep in. You're rewriting the entire code base. Of course, you're not going to do it perfect. Every time you make changes, it's more likely that bugs are going to creep in. The third one is that you are often making many changes at the same time. And that means that you cannot see the effect of these changes in isolation. So you are not really sure whether what you're doing is correct or not. So instead, you have to cut it up. If you want to tackle a bigger problem, try to make small slices and work on them individually. Because only in that way can you work effectively. And perfection is the enemy of done. It's way more important to get something ready than to keep, have it lingering on a branch. I'm not sure, maybe we should look at it again, work on it for weeks. No, instead you want to be done quickly. It's more important to be done than to be perfect. Of course, it doesn't mean it has to be bad. But if it's not perfect yet, you can just iterate on it, because we're not trying to do the one big refactor. We're going to do it small. We're going to continuously refactor little bit by little bit, iterate. Because very often you just merge code and you're not even sure whether it's a good idea or not. Well, just fix it a week later. One thing that I personally really like to do is to put my refactors behind a switch. So this can be, for example, an environment variable, or it can be a feature switch or an experiment, depending on where you're working. And this has, and then what you do is you just have a piece of code, you basically duplicate what it does, you put a switch in front of it. If this is true, then do that. If otherwise, do that. So this has 3 really big advantages. The first advantage is that it makes sure that your master branch is unblocked. So one thing that can happen, I've seen it happen before, is someone refactors a big piece of code, merges it to master, goes to production, or main, goes to production, and there's a bug. Oh, it's a pretty bad one too. It happens, so you roll back. I think you should always roll back. Don't try the hotfix. Only makes things worse. So you roll back, but what happens then? So if you're working with multiple people on the same code base, then suddenly master is blocked. Other people cannot merge features anymore. So what you have to do is you have to revert your merge request as well. And then suddenly it becomes a burden. It becomes really annoying, because the next time you merge it, you have merge conflicts again. And it has a lot of time. So building in a switch prepares you for the worst. What if it goes wrong? Too many people always think about the happy flows. Of course it's going to work. I'm the greatest programmer alive. The second reason why it's good is that it forces you to work small. Building switches around code is really, really annoying. I hate it. That means that you want to switch in as little places as possible. And that means that you get a really neat structure of making sure that it's an isolated refactor. And of course, it's not just one class that we're touching. We're changing the structure of the code. But it can be a bundle of classes where you're switching between functionalities of the two, because you're just making a second branch. The third one that's also pretty nice is that you have the old and new code next to each other. So if you're wondering what the old code was doing, well, you can just look it up, because it's still there. It's really annoying when you're halfway through a refactoring and you're wondering, like, oh god, what was the code doing again? Of course, there is one big downside to switches. You have to clean them up. And this is very hard for many people. And one of the worst things that you can have is good code, but everything is behind switches that are never cleaned up. And the old code is still there. Very confusing to read. I briefly wanted to touch upon tests. So there is one really big problem with refactoring, and that is that you're changing the unit. So by definition, your unit tests are probably going to break. This means that you need to have very good suite of integration tests. And that is something that a lot of developers don't really like to have that much. It's very important to have good integration tests, because your unit tests are probably going to all break, or you're going to have to rewrite them anew. And if you have to rewrite all your unit tests anew, then they were not, you were not really relying on the old ones, so you're trusting your own work. So one thing that you might sometimes want to do is to write integration tests before you refactor. Because if you have good integration tests, I mean, generally, if you have pretty good integration tests, they should mostly hold when refactoring. Of course, there's cases where this doesn't happen. Then you should maybe have some end-to-end tests in place. I don't know. All right, so we've set a pretty clear goal. No, we've thought about it long and hard. We have one goal, reduce duplication, for example. Then we've built it, maybe with a switch, maybe without a switch. We've made sure that there's tests. We even wrote new unit tests. Very proud of that one. And now it's time to reflect. So it's very good to sometimes take a deep breath and look at your code and think, is this a good idea? No, I reduced duplication, but at what cost? Maybe you introduced something that is really hard to read, or you introduced all of these interfaces that, in hindsight, seem like a pretty bad idea. And you should also look at, well, did I actually achieve my goal? You set your goal, you reduce duplication. Did you actually? It's very good to have a look at it, and this is why it's important to have a trigger. You should also look at, am I solving my trigger? Sometimes you find out that you actually set the wrong goal. You set the wrong goal, you try to fix that, and then you look at it and you're like, well, we had this retro about how hard it is to add a new field here somewhere, and it's still really hard. And sometimes that means you just have to, scrap it. You made a mistake, didn't work out as expected. Scrap your code, try again. Sometimes you can also say, well, perfection is the enemy of done. It's good enough, let's merge. And then we'll iterate. We'll iterate and fix it tomorrow or next week. And of course, it's also very important to not reflect by yourself. I think, even, none of what I've been explaining, you should have been doing by yourself. If you want to set a goal, talk to your team. Reflecting, talk to your team. Have a good discussion about it. Don't just send them the merge request and ask for an approval. Discuss with them. Do you think this is actually a good idea to do in the future? And that's the last thing that I wanted to touch upon, and that is communication. Communication is very hard for many developers. I'm extremely introverted myself. I really hate talking to people, but it's very important for a job. You have to always communicate very clearly with your team. Do people think this is a good idea to refactor the code this way? Is there time for this? Are other people touching the code at the same time? But even more important than that is communication with your product manager or your product owner. One of the most important things is to be honest with your product manager. Your product manager is, in charge of the product and is responsible. If you are in a stand-up and your product manager asks you, look, you've been working on this 2-point story for a week. What's going on? And you tell them, nothing, taking just a little bit longer than expected. Meanwhile, you're deep in the trenches, you've been shoveling all that garbage, you've been refactoring for 4 days. You can't do that to them. They have to trust you. Because the problem is, they're not developers. The most important part is that you shouldn't see your product manager as a hurdle. In my opinion, if you shouldn't even get to the point where you're 1 week into a story and your product manager has to ask what's going on. If you're looking at the code and you're like, well, to accomplish what I need to do, I need to refactor some code. Talk to them. Just tell them like, I have to refactor some code. May take a little bit longer, but we'll get there in the end. Don't worry. But you shouldn't see them as a hurdle. Instead, I think you should see your product manager as your good friend, because all that they want is for you to have good code, so that you stop bitching in your retro about the bad code. So the problem is, the product manager is not a developer. They're not technical. It's really hard to convince them with arguments. You can talk all about blah, 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 duplication, blah, blah, code patterns, and their eyes are just glazing over, and all they hear is, I need 3 weeks to waste on this refactor. And they're just going, oh my God, we have the deadline in 2 weeks. I don't have time for this. Can you blame them? No, of course you can't blame them. The problem is, because they are not developers, the only thing that you can do is to build up a mutual trust with them. You have to show them that you can refactor in time, everybody's happy with it, and they don't even notice. If you go to them and say, well, I need to refactor this code, and all they get is nightmare flashbacks from that one refactor story they put on the backlog, that took 4 weeks, then it was merged, bugs on production, had to revert, teammates complaining, then they're going to say, well, maybe after all the deadlines that we have for the next 3 months. Instead, if you tell them, yeah, I want to refactor some code, and they're like, oh yeah, the last 5 to 6 times you did it, it cost only 2 days, everybody was happy with it. Of course they're going to say yes. But you have to rewire their brain, because very often they're wired to think refactoring takes time and nothing comes out of it. And lastly, the thing I wanted to touch upon is the slide that nobody ever mentions. Everybody's always saying about how we have to do that, how you have to. Nobody ever talks about when you shouldn't do that. And there is a point where you have to compromise. If your product manager says, it's really fine and dandy that you want to refactor this other code, but we have a really strict deadline, sometimes you just have to suck it up and say, well, okay, then we don't do it. Sometimes you have to think and be like, well, I can refactor it, but the code is also already kind of okay. It's doing what I need. In those cases, just don't refactor. If there is a deadline issue, one of the things that you can also do is to think of a compromise with your product manager. Now, actually use technical debt in the way that it was designed. You first build a dirty hack to get it on production as soon as possible, and then you refactor the code immediately afterwards to make it neat and build a proper solution. Then at the end of the day, everybody's happy. Of course, there is a downside. You have to build it twice. But, at least the end result is better. So, to sum it up, I think that there are 3 important things to do. You have to refactor as often as possible, as many times as possible, not only to build skill, but also because you want to keep your factors as small as possible. You want to keep iterating and iterating and iterating. You can never build code perfect on the first try. You always have to learn from your previous fuck-ups. You have to iterate. And the third most important point, you have to keep communicating. You have to keep communicating with your team and also with your product manager, because otherwise your trust is going to break down. Now go out there and start doing some refactors. Thank you. I talked a little bit fast, so we still have time for questions.
So, do we have any questions in the room? I don't have that bad aim, so don't be scared.
Damn, I should have talked slower.
Okay, well,
if there's no questions.
In that case, I would like to thank you, Stephen, for your great talk.
Oh, there's a question over
there.
there.
There's a question. Okay.
I can also talk for like 7 minutes about random topics that people give me. Easily.
Yo, is this working? Okay.
Yes.
So it surprised me a bit when you said refactoring is the thing beyond those 7 steps in the IDE. Can you tell a bit more about why you think it's more than just those 7 steps?
Yeah, so I think that Boy Scouting in your IDE are the things that are trivial and the things that you should always be doing. There is no single reason to not just rename some clause in your code. It's free, and the only problem is that it sometimes clutters up your merge request. So sometimes, it might actually be useful to do it in a different merge request or a different commit so that it's easier to read. But generally, it's just free. So you should always do it. Though I personally think that extracting variables is something that is extremely overrated. You shouldn't always do that, but it's personal opinions.
Yeah, I'm still curious. So do you actually use those automatic IDE suggestions, like extract methods, move inline, etc.?
Yeah, of course, all the time.
Do they help you refactor faster, or do you also have to
but I see them as a general. It's a general tool, just like auto-completion. So I use them all the time. Yeah, of course it helps you refactor faster. But I think that, for example, inlining code, it really depends on the way you're doing it. Like if you're inlining methods from a different class, it suddenly becomes a little bit more refactory. But generally, yeah, sure.
Thanks.
Hey, just curious, because there's still time left. You mentioned a horror story of a refactor. Can you also mention some refactor story where everything went quite smoothly, or where there was a challenge, but you solved it and everyone was happy in the end?
Whew. Well, there's quite a lot. So, so there's maybe also an interesting one for a learning as well. I was the sole maintainer of a piece of code that's called Runway, which is the rendering engine of the webshop. And when I got control over the code, it was in a kind of bad space. So it had originally been written as a very light thing, but we wanted to put more responsibility in it. And so what you saw is that the responsibility of the code had changed, so the requirements had changed. And one of the problems that it had was it was a big code generation engine that was then used in the webshop code. And the generated code was pretty ugly. It was not that great to use with. It was not really, Java 8 ready. And I really wanted to change that. So this actually took me a very long time because I did it in a lot of small steps. And I would do a small step like change the generated code to work with interfaces. And then I had to make 1,000 changes in the webshop code because they were all breaking changes. But I did only that breaking change, put it live, next one. And then bit by bit, I could replace all of the internals and then eventually build new generated code. And the way it worked is that it was by default generating both the old code and the new code. And then in the webshop, you could choose which one you were using. The default would always be the new code. The problem was that there were 8,000 classes using this generated code. And all of the new code was using the newly generated code, but the old code was still using the old generated code. And it actually, it's still there. So the problem is that if you tell people, all right, we have got all this awesome new code, now go refactor your stuff, is that people don't do it because it's too much work. They don't have full control over their backlog, and this is something that has to be structurally picked up. And we have had a really big problem until one day one of my teammates said, this rewriting is actually pretty fun. I'll do it every Friday of the week. And then he just worked on it every Friday. And I think that we're completely done except for 1 or 2 classes. And hopefully I can finally clear up that 5-year-long refactor soon.
Your teammate sounds like a hero.
Yeah, he is. Give it up for Marco.
Do we have any other questions?
Oh, I see multiple.
Give me my box back. There, you can throw it there. All right,
Okay,
then we have
there
another
you
one here.
Hello. I want to ask your idea about refactoring as a part of stories. For example, we want to do a story and we see a merge request with 25 files changed, which 5 files only resolve the actual story, but with 20 files doing the refactoring. Then it may not take a lot of time, but we have a huge merge request, which like a lot of it is not necessary, mostly refactoring, but yeah.
Yeah, I think that's an interesting part. And one of the things that I actually don't really like is to have refactorings done at the same time as a feature request or an actual, business request. And this is because what you said, they start going through each other, and you have a really tight coupling between these two. And what you sometimes see is that, the newly added code is actually good, but there's a bug in the refactoring. And then suddenly these are too tightly coupled, and then you still have to revert. In cases like this, it's sometimes good to do a refactor before your user story, so that you split them up in 2 of them. The downside is that this also becomes sometimes a little bit weird, because if you're refactoring to be able to do the new user story, then you have to refactor code, and then hope that you can do the new user story, and you're not really sure, so you do have a really clear trigger, but it's really hard to test and reflect that what you did was good enough. but that's a little bit of a dilemma. It's hard. It's a gray area. Does this answer your question?
Kind of, yeah.
Right, good.
Cool. We have time for one short
Yeah.
question. I think we had it here, so throw it hard. Come on, you can do it. Okay, someone's getting hit. Thank you. Yeah, sorry about that. There you go.
Hey, thank you for the talk. And my question is, let's say you want to refactor something that goes over multiple services. Of course, you can do it in a very cautious way and do step by step and to avoid that something breaks. But do you have any advice to speed things up and still achieve a good result if you have a refactoring over multiple applications?
Ooh, that's a tough one. That's a tough one.
Sorry.
No, that's okay. It's a good one. Try to get people on board. Try to make it small, and just do it. Which is not really that useful, I think. Sometimes it's just rough. Sometimes it's just shit, and you cannot really do anything good. Sometimes we are put in bad situations, sadly.
Okay, thank you.
Cool. We are out of time, so I would like to thank Steven for this great talk. I think we can all relate. Also, I'm sorry if you ever had to refactor some of my code. Just wanted to say it in front of everyone. So please give him a very warm applause.